Sup guys, welcome to today's show. So in the last episode, we started creating our own Linux distribution, no bloat Linux. And we succeeded in booting up our virtual machine and getting a bash shell. So now we need to make the other programs work. So we have this far finished bash, Busybox, glibc, as well as the Linux kernel itself. But we also need a couple of other things. For instance, we need this util Linux package, which contains the SFdisk software that we're going to use to partition the target disk. Today we're also going to start creating the actual installation program. We're going to have to recreate the ISO image a couple of times when we improve our system. So let's make it a little bit easier on ourselves by creating a script for that. So let's see here. I think the easiest way will be to connect to the Linux server, because it's probably still working in the background creating all of these directories. So let's go in here and NB Linux. It's starting to become quite many projects here. And phase 1 and scripts. So this should be very fast. There we go. So let's create two things. Let's create the make file, which will be very simple. All it's going to do is call our script. So let's call this make ISO, which we'll just call like this. And then we will create one more thing, because it loses the 755 privileges when I update the file. So let's change mod it every time. And this is the make ISO.sh. Okay, so first we need to create the, let's see, the CPIO, so the zip file basically with the whole file system. And let's see if I find my terminal. Alright, so let's see if I still have the command in my history. That's good. And we need to cd into the correct directory, so it's this root directory here. So we want to run this thing. But first we want to cd into the directory. And we need to be able to return to this directory afterwards. So we could do something like this. Create a temporary variable which contains our current working directory, and we could go up one step and into root, and then afterwards we can go to the saved directory like this. But there is a better way when doing this stuff. Let's see. This one, push D. So there's a push D and there is a pop D. So when you push the directory, it saves the current working directory on the stack, so it's able to return afterwards. Pretty nifty, actually. So what we want to do is we want to push the directory and move into the root. And when we're done with that, we want to pop the directory. Like so. So that's one thing. The other thing is the kernel stuff, which we did, let's see. Okay, we don't have it. So we need to recreate this thing. ISO, no, make help. So we have FD init RD, we have FD args. And this should point to what do you call it? This one, init RD, CPIO GC. So let's see here. We want to push D into the Linux directory. Inside of here, we want to run make and provide some of the arguments. So FD init RD should be init RD CPIO GZ. Then we have FD args. That's the one, right? FD args, that's right. And here we want to say init RD should be slash init RD CPIO GZ. And we had one more argument. Console should be TTY S0. And it does not quite fit on the screen, which annoys me. So let's do this. Right, and when this is done, we pop D again. And let's also put into the make file let's do it like this. Let's say we have a kernel. And inside of kernel we do this. And then we say all is kernel. Because now we can provide a dependency here. and I want this to be dependent on the config. Let's do this. Let's call this image. And we want to do the kernel and the image. If the kernel config has changed, in that case we want to run another script, make kernel. So if we change any kernel configuration, this will detect that and rebuild the kernel. Otherwise, it will just do the image. This will make our lives quite a bit easier. So make kernel.sh. And we'll do the same thing here. We want to push D into Linux. We want to run make -J8 and pop D. All right, let's see what happens. I'm not sure if it's going to rebuild the kernel once. Maybe it will, but let's let it in that case. So we should just be able to run make here. Seems like it works just fine. But did it do it in the wrong order though? Let's see here. First it did make kernel. Alright, and then it made this one. So I guess the next time we run this, it's not going to try to rebuild the kernel, because then it knows the config has not changed. But as you can see, everything worked out, and now we have a new image and a new init RD, as you can see here. Okay, pretty nice, pretty nice. So now we're able to fix a new image quite easily. Let's see if we can compile these other things. Let's start with util Linux. And if we run configure-help, are we able to put in some libraries of our own? Seems like. That's good. Do we still have that variable? No. What did I call it? rpath. Alright, so these we want to add. So let's set this libs equal to this. Okay, let's do it in 2 steps. With quotes, let's export libs. It's quite cool that we can tab environment variables. Okay, so now it's going to link against our glibc, our own glibc. And do we have the root variable still? We do. Good. So now we should be able to run configure. Prefix is equal to root. And hopefully this thing will compile. And why not do LILO at the same time? So LILO is a Linux loader. It's like a tiny version of grub, which will suit our intents and purposes perfectly. So how do we build this thing? Use the shell variable dist dir, okay? But what do we do if we wanna add some additional things? Okay, so we can make it a static binary. That's good in case we're not able to add these glibc stuff. Very simple makefile, I like it. So let's see here, CPP. I guess we can add it here, probably. Or C flags. This is probably the thing. Right, so let's add it to C flags. So I'll just copy this thing and set mouse equal so we can paste properly. Okay, so we add this stuff. Okay, there is a libs here, but it's being set to this dev mapper, so let's put it inside of C flags. Do we need to add alter any other ones? Source images. Hooks, sample, scripts, man, tools. So what is images and hooks? Doesn't say. Let's add it there as well, just in case. So images, make file. Okay, there's no C flags here. Make vars. User bin dir. Let's remove that. Okay, and what was the name of the other ones? We had images and we had hooks. Okay, we don't need to do anything there. Okay, so dist dir. Let's see what happens. GCC version 3.3.5 or later. That was a while ago. So it does now it sets it okay. BCC is not present. You will not be able to make floppy. I'm okay with that. AS86, LD86. Let's remove this 86. And let's try again. It's always a little bit tricky to compile this old stuff, but let's symlink those things. So So AS becomes AS86, LD becomes LD86. And let's try again. Okay, something is happening, I guess. So let's see, util Linux, liblastlog selected but required SQLite. Liblastlog. Can we deselect liblastlog? Because I don't really think I need something with a library here. Disable liblastlog. I like it. Okay, this doesn't look too good. Let's see where that GCC check is. Check it. So let's just do exit 0 here. All right, it's building. And this passed as well. So let's make this like so. Okay, now what? Unrecognized option for the linker. Okay. Let's skip that one. We do get a couple of warnings, but -L. Well, let's remove this L and see what happens. Seems to be an Intel syntax. First.s. If we go to the man page for LD, is it possible to use Intel syntax? Intel shadow stack. Let's Google for that. So Linux LD, no, not LD, it should be AS. Mnemonic is equal to Intel, could that be it? There, well, let's try. You still get a lot of these errors. Is it possible to compile this stuff with N as instead? It's only 2 source files as it seems. Okay, this syntax doesn't work. But if we were to, let's save a copy of this. And let's do some Vim magic. Let's change every equal sign to EQ. That should pretty much be the same. Comma colon decorated 11. Oh, it's using an exclamation point instead of a regular comment. Let's do some more Vim magic and let's search for every exclamation point followed by anything and end of line and just remove that stuff. 12 instruction expected. There wasn't a space here. Well, let's do this again. I'm glad I made a copy of this thing. So let's search for equal sign, change it to space, EQ, space, like so. And now we remove all these weird comments. Let's try again. 76. Get command.s. Global. I think it's too much work. Is it possible to install that AS86 stuff? Huh. It is. Let's remove those symlinks we did. Okay, so it's a 16-bit assembler. I see. That kind of makes sense because this bootloader is going to be run in 16-bit real mode. Right. I think we need to unpack this LILO. And let's see, what did we change here? We need to add this stuff. And we need to change the directories a little bit. This should be var boot, and this should just be sbin. And in this make file, we just want to add that stuff into the C flags. Right, so let's see if we can run this thing again. Okay, we passed the test this time without me altering the file, so that's a good sign. Okay, we almost got it done. Multiple definition. But almost everything got built. Maybe the old GCC had some other way to distinguish between those multiple definitions. So when multiple symbols exist, I guess it was able to handle it before. So I guess we can probably add some switch to GCC to make it act like it did back then. Or to LD rather. There must be some way to let it differentiate and select a symbol based on some criteria. Allow multiple definition of symbols. Here. So let's see, what do I need to change? Let's add it to the C flags, because it seems to be the GCC command that does this. So let's see, we need to pass this to the linker. Yes, that we need to use the W. Is it like this? WL. Okay, something's happening. decode. I think we maybe get this to compile. Okay. LILO, will you look at that? So let's see if we can install it. Seems like. And we have LILO. And it's using the correct interpreter. And the correct R path. All right, cool. Let's see if we can make a new image by just running make inside of here. And let's see if we can run LILO when we have restarted the virtual machine. Alright, so the CPIO is created. And now we make a new ISO. Okay, let's see what happens. So we run vm-cd-rom and we load in this image. So let's go into sbin. Where did we put it? It's there. It's there, but it's not there. That's weird. Why is that? There must be something wrong with our script, because okay, it generated this file correctly, but not the ISO. But it said it did, I think. Oh, I forgot the switch. That's embarrassing. We need to add ISO image. Alright, let's do this again. Meanwhile, let's start the compilation, or it's done already. Okay, that's cool. Let's see if SFdisk looks right. Okay, it's even static, so no problem. But how many megabytes is this? 154. Maybe we should only copy the stuff that we need. So let's take SFdisk, SFdisk, and just copy it into the root sbin directory. Maybe we need to remove the symlink first. No, we don't have any. So into util-linux, copy SFdisk, SFdisk into the root sbin directory. Let's make again. So we almost have everything for this this one. What about Sys V init? That's next on our list. Let's change mod these. So we see that they are done. And same with LILO. Alright, let's unzip this thing. Alright, this is done. So let's test this now. So we run VM cd-rom is image ISO. So hopefully now SFdisk should work, CFdisk should work, and LILO should work. it works. We get an error because we don't have the configuration file, but it obviously executes correctly, which is nice. What about SFdisk? This script is just a wrapper for SFdisk. What about SFdisk? Okay, so I copied some script instead. But LILO works, so we're at least one step closer. Okay, so where is the real SFdisk? Okay, so there's an ELF binary. What about this script right here? Temporary wrapper script. Okay. Alright, so let's run make install here instead then. We got a couple of warnings, but it seems to move along. Let's check our root sbin directory. SFdisk. Okay. But it links against this path. Maybe that works out anyway. Let's just change this manually. So set our path to lib. Let's do the same for SFdisk. Now I believe everything will work. What's this? libsmart calls. This probably got installed inside of this lib directory. Yes, okay. Then I think this will work out. Let's take Sys V init 2 before we do anything else. R path. So we need to add this stuff to our make file. C flags. So let's add this. And we do not want a user bin directory. So let's add these to bin instead. And let's see, what else do we need to change? Man dear. What else? We need to set the destination prefix as well. Install directory. -m-d. Okay, we need to change root. root. Alright, and many of these programs will they are currently symlinked, so we need to delete all of them. So bin and sbin. We need to iterate through these. So let's do something like for I in bin and sbin, so we want to delete that thing. Yeah, let's do it like this. So if it exists inside of the bin directory, in that case we want to delete it. And else, if it exists inside of the S bin, we want to delete that. So something like this. And then we do the installation. So now we should just be able to do make root is equal to root. And we should skip that one. So that's this stuff. Let's skip this login, we don't need it. Now I believe everything will work. Yes. And what if we run install? Then unexpected. I don't often use if statements inside of make files. Okay. Alright, so now I have a proper init. And it's linked correctly. Very nice. So we're almost done with this thing. All of these packages are successfully installed. We do need one more though. One that is called dialog. We need that for creating the GUI. And I'm not sure if it's a GNU thing, but I think it might be. So let's see. Do we find dialog here? We do not. What if we were to go directly to one of these subdirectories? No, not there. Dialog. Nope. Let's see, author is Thomas E. Dickey. Here it is. Because you should never, if we just were to just go to Google and search for Thomas E. and dialogue. Okay, what is Thomas E. Dickey? And you see the first hit here is from some invisibleisland.net. So often when you search for a program, you get these weird links on top, which are probably backdoors or viruses. So always try to find the Wikipedia page and go to the whatever they link to. So let's see if we find a new enough version. Here is a tar GC from this year. So copy link. And when this is compiled, we can successfully start building the installation program, which is going to be rather fun actually. Alright, so how do we build this thing? There is a configure script, I like that. Let's see if it takes a libs variable. It does not. What about prefix? That it does. Maybe we can add it manually to the make file. Alright, so let's run configure prefix is equal to, do we have this root thing? I don't remember. Yes, we do. Right, let's run this thing. And let's add this. So it's a configure script that does not create a make file. That's a bit weird. There is a makefile with a small m. I'm not sure what that means. But let's try that. So let's see, where can we add stuff? Let's use C flags. Did it take our C flags? Xlinker, yes it did. Right, seems to compile. And it seems to be linked okay. Let's see. Patch elf. Okay, that's good. So make install. And there it is. All right. So now everything is done. Let's create a new image and see if it works. Everything has actually worked pretty much. Well, it has gone on Rails. Everything has worked. So let's go to scripts and run make. And hopefully SFdisk will work, SFdisk will work, init and all that stuff will work. And maybe even dialog. So let's see, it's creating the new archive, the CPIO archive. Now we're creating the new disk image. And soon we'll be able to try it out. Almost there, okay. Image.iso. There we go. Okay, so let's try this thing. All right, so let's run dialog. libn curses, all right. Let's just copy lib and curses. So SO6. Okay, points to the 6.4 thing. So let's copy this file to, do we have that root directory? Yep. So we copy this to root lib, and it should just be called this. Oh, this should be root like this. Okay, that's good. Let's check if the other stuff works. So SFdisk. Okay, so this requires the other end curses. So let's take that as well then. Not really sure what the difference is, but who cares? User lib i386. So this is this one, lib and curses w. Should go to $root lib and this. Boom. So I guess the SFdisk uses that too. No, this actually worked. It requires proc though, which we haven't quite mounted yet, but it seems to be working. Alright. What about the init stuff? So can we run level, for instance? libc so6. So phase 1, root sbin. Okay, it did not get the R path. Why is that? I wonder, can we do something like so we search for all files, so not the symlinks, and then we execute patch elf, set our path to lib for that file. This should be type. And let's do the same for sbin. So if we go back into bin and we do this command on run level again, inside of sbin. Okay, so now it has the correct one. And everything should have the correct thing. So let's create the init tab and the root user. So let's go into, okay, we don't, let's do this. Let's create a sys directory, a proc directory, and a dev directory. Let's create a password file. So it's divided into several parts. First is the username. Then we have the password, which I'm going to leave blank. Then we have the real name, let's just say root user, followed by the home directory, let's say / and default shell bin sh, something like this. We also need to create an init tab script. So let's see if we can get, let's go into var share man5. Check the init tab so we get an example. Let's use this for now, etc. Getty. Do we really have that inside of etc? No, it's inside of sbin, I think. Yeah. So let's create init tab and paste this in. And etc. rc. This should be sbin getty, and the terminal should be s0. Okay, something like this. And let's create this rc file as well, which is going to be run once every time the computer boots. So here we can mount the directories. So we want to mount type proc proc. Want to mount type, what's this called? TMP, is it TMP Sys FS or something? Let's see. If we do mount and we grep for sys. Okay, so this is just called sysfs. What about proc? Did we get that right? Yes. And then we need dev. Okay, so type is udev. No, type is dev tmpfs. Okay, I was right. But this should be udev. Okay. So temp dev temp fs. udev to dev, and then we have sysfs, sys. Something like this. So now we should get a proper terminal and a login prompt. We need to remove this link, and instead of bash we want it to run sbin init. Okay. So now the actual Linux system is pretty much done, at least for phase 1. So all that is left is the installation program. But let's try it out. So let's first generate a new CPIO archive. And hopefully we'll be able to log in when we get that far. Alright, the CPIO archive is done. So now we are creating the kernel ISO image. And it's almost done. So it's generating. And there it is. Alright, let's see if everything works now. So we run vm-cd-rom and we take our image. And let's see what happens. And by the way, now we don't need this console thing any longer, because now we will have a proper terminal. ISO image. Ah, look at this, we have a login prompt. So let's say we are root, bad record, annoying. What did I get wrong? Oh, I forgot the UID. How lame am I? So first we have username, then we have password, then we have UID 0, then we have GID 0, and then we have all of this. Of course. All right. Then we'll do this once more, which is probably the last time before we can start creating the installation program. So while this is compiling, I'm going to show you how this dialog thing works. So dialog is a program which generates those ncurses style dialogues. So for instance, we can say that we want to have a message box with a message, hello world, and we want a height of let's say 5 lines and a width of 40, something like this. This should be message box, and we get this. Pretty simple, eh? And we're not limited to just message boxes. We can get let's say we have a radio list. That asks us where to install Linux. And let's say this window is 10 lines high. And the actual choice can be 3 lines. And let's say the first tag is that we're going to install it on SDA. And let's say this is 512 gigabyte SATA disk or something. And the status should be on, let's say. So now we have one of these. And we can choose between many. So if we have an SDB, for instance, let's say 1024 megabytes serial ATA off. Then we have 2 different options. So it's very easy to use this. And we can use the return value. So if we run this and then we echo, what is it, $%, I think. So if you check the first alternative, no, it's not $%. Let's see the return value. $? Alright, so if you check the first one, we get a 0. If we check the second one, we also get a 0, okay. So that's not how it's used, but it's something similar to this. We need to figure out the details, but this is basically how it works. All right, let's run this now and see what happens. So it's booting up. And then it's going to execute init, which will run the scripts, and it will also get everything ready. Okay, we got a prompt. Log in as root, and we are logged in. It looks a little bit weird, but we can reset the terminal. And we can even use the arrows, so we have a proper terminal. It looks weird because we haven't set the PS, but we can do that. User at host $. This should be PS1. Alright, so now we actually have this, and let's set the host name. So let's call this Linux. We set this like this, and we do bash. So now we have a real prompt. And let's try dialog. It works. Let's try SFdisk. We don't have a hard disk, so that's why it's complaining. What about if we run SFdisk with this? Yeah, so SFdisk will list the different partitions, but we don't have a hard disk currently, but as you can see, it works. And what else did we install? SFdisk, SFdisk, dialog. We've tried init, same with LILO. Maybe that is it. Does run level work now? Does. Doesn't know which run level though. We do have an init default. We can figure that out. Not a big deal. Okay, and let's see here. Do we have a dev directory? Yes, we do. And sys and proc. Pretty cool. Okay, so I guess that's pretty much it. Have we gone through everything? Util-Linux, Sys V init, LILO, glibc, dialog, Busybox, bash. And we do have the right. This is from before. We do have the right bash, I think. Yes. Okay, we have a proper Linux distribution, however tiny one, but everything we have installed works. So let's just create the installation program, which will be very simple. It will only welcome us to the installation process. Let us click install and then choose which hard disk drive to use for the installation. Then it's going to partition and format, and then it's going to install the basic system into it and install a bootloader with LILO. And that's pretty much it for phase 1. Then it's going to reboot and continue the installation from the Linux on the hard drive. So this is enough for this session. After the break, we will start coding on the installation program. See you just in a bit. Alright, you guys, welcome back. So, let the fun begin. Now we're gonna start to code the installation program. And the first thing is going to be the partitioner, which means that we need to have some way of listing available hard disk drives. So that's the first thing we need to do. So inside the script directory, I'm going to create a new file. Let's call this partitioner.sh. Alright, so usually the name of the different disks in Linux are called SDA for the first, and then SDB, SDC, and so on. But I'm gonna create virtual disks so far, so we can test against that. So I'm gonna call my, let's say we have a prefix, and I'm gonna call my XDA, XDB, etc. And then I'm gonna change this when we get it to work. And let's also say we have a dev directory, which usually is /dev, but in our case, let's say we create a directory here, which we can call disks. And we are currently at this path. So our virtual temporary dev directory is going to be this. All right. So how do we figure out which hard disks we have? There is a command in Linux which is called dmask. So if we run sudo dmask and we grep for SDA, for instance, we get an output similar to this. Let's pipe it to more, because we need to create a temporary dmask with our virtual disks here, so we can test the script in a similar environment. So let's see where we see the disks. This doesn't look too good. So let's see here. Alright, so here it's the stuff about SDA, etc. So let's grab a piece of this. So we have some additional input, so we can parse it properly. So let's just create some file here. Let's call it dmask.txt. We paste this in, and then we take this part, which has to do with disks, and differentiate it a bit with some spaces. So let's see. So all of this input right here, we can expect to get for each disk. So let's say we replace SDA with XDA on each of these lines. Let's try this again. So we want to change SDA to XDA. Weird. It should repeat the last thing. Must be a bug in VS Code. Alright, let's do it manually. So this is XDA, 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 XDA. Same here. And this is XD, XDA. And this right here is what we want to call the disk. This is what we want to show as an alternative in our program. So this should also be X. All right. And we want to test it in a way so we can have multiple disks. So let's create 2 more of these. Only here it's going to be called XDB instead. Something like this, and this will be XDC. And let's also change the description of these two. So this will probably be the same. Let's see, 32 gigabytes. So let's see, let's make this megabytes instead, so we don't have to worry with this big stuff. And let's say we have a small disk of 10.0 megabytes. And maybe one with 15. Mega, and this should be 15 M. Okay, so now we have something to work with. So let's remove these extra spaces. And let's say that this is our dmask. And inside of here, let's create a temporary alias. So let's say that the dmask command instead is going to be, let's copy this right here. The dmask command is going to be cat and this script dmask.txt. And let's try to run dmask like this. So we save this, and inside of our make file, let's create one more thing. Let's remove this kernel part. Let's create something like part, because I don't want to type the whole partitioner all the time. So we want to change mod partitioner.sh, and then we run partitioner.sh like so. So what happens now if we run make part? Did not really take my alias, did it? That's a little bit weird. What if you make a function out of it? Something like this. Okay, now it works. Good. So now we have something to work with. So we need to be able to parse this thing right here. So let's see how we do that. We could start by grepping for space xd space. Now we have all the information with regards to the disks. Maybe we could start by grabbing these different ones. So let's pick one of these lines. Or maybe we can do some sed magic. So if we sed -e for extended, and this is inside of brackets, which should be easy enough to single out. So let's say we sed everything, and then we get a bracket, and inside of here we have something from A to C. have another bracket. And then the rest. So if we want to change this to foo, let's say, maybe we should do a star instead of the plus. Alright. So instead of changing it to foo, let's put a backslash parenthesis here and after the asterisk, so backslash parenthesis. So that means we single out this input and we can use it here as an argument. So this is the first argument then. There we have it. So now we just need to sort this and unique it. And we have individual things. Okay, that's good enough. Let's copy this thing. So let's see. Let's call this enumerate disks. And we run dmask, pipe it like this. Let's try it, enum disks. Alright. So now we want to put this inside of a inside of an array, right? So how do we make an array in Bash? I don't think I ever done that. So let's say we have a variable called foo. Can we just do foo 0 is equal to 1, foo 1 equal to 5, echo foo 0. Maybe foo 0. Ah, there we go. Well, okay, cool. So how do we put this inside of a variable? Put this inside of this array right here. So let's see, we need to do something like enum disks while read x do. We need to set some counter first. So let's say we have an n which is equal to 0. And we set disks n equal to $x. And then we increase this. What happens, by the way, if we just echo foo? Okay, then we get the first one. nice. I like language where you can just figure out stuff if you don't know them. Then they have succeeded in making everything logical. Alright, so after this loop we should have one of these arrays. So we should be able to echo dollar disks star make part. No, that did not quite work. Now what? Did I get disconnected from my internet? No. Weird. I get a lot of packet loss. I don't like that. It's in the middle of the night though. Maybe they are restarting some switch or something on my ISP. Well, it seems to be working better now. So let's see. Make parts. Text file busy. Maybe something went wrong. I probably got disconnected here as well, right? Let's resave this file and it should be updated. Okay. Okay, so why doesn't this work? We enumerate the disks while read x do disks of n. The n is 0. Maybe we need to do $n. And what if we just do disks like this? Still get nothing. Let's try a for loop instead. So for x in this do, and we try this again. Okay, Now it's working. So let's try this star. Okay. So now we have an array with different disks. What else do we want? We want another array with the information. So if we grep XDA, for instance, inside of dmask, we want to grab, let's see, we want to grab this part, right? Okay, so how can we differentiate this first line here? Does it always say this 512 byte logical blocks? Well, it probably says logical blocks at least. So if we grep for that, then we get this line. And I suppose this is always similar, and then this and this and this. Maybe sed is the easiest way. So if we sed everything and we go to logical blocks colon space, and then we have a literal parenthesis. Inside of that we want to have this backslash parenthesis so we can grep for stuff. And we want everything inside of here. Until the end of line. So $. We probably need to do sed-e. And let's take this capture group. That did not work. Logical blocks. Okay. That was quite easy. So what are we going to call this? Enumerate. No, we're not enumerating. We're getting. Let's say get description. So we run dmask, and we need an argument here. So let's say we have a local variable which is called, let's say dev for device. Dev should be equal to the first argument. If dev is nothing, then return 1. Otherwise we do dmask, we grep for the dev, then we do this, let's break it up. Return 0. So let's say we create some temporary variable and we run get desk of disks 0. And we print it, we're using printf this time. Okay, that works fine. So now we just need to do this for every disk. So we need to iterate through that array. So I guess it's 4x in disks star, I guess, do. And we want another array, so let's reset n to 0. And let's call these the desks for descriptions. $n should be equal to $x like this. We increase. So now we should be able to echo, let's say, disks 1 and desks 1. See if we get the right thing. Wrong syntax. Oh, this is not right. This should not be equal to x, it should be equal to get description of $x. That's the one. All right. Nice. This was actually a bit easier than I expected. So what else do we need? We need to have the name of the device like this. And the description. What else do we need? I think that might be enough actually. So let's create these disks. So let's grab logical blocks. Let's go into the disks directory, and we can use dd to create. So we will fill it with zeros for now. So input should be dev 0, output should be xda, block size, let's set it to 1 meg, count, let's see, 32.2. What if we were to add a parenthesis here, divide it by 10, and we say this should be 322. Well, close enough. So let's do the same with xdb, and this should be 10, so 100, and xdc 152. All right, so now we have these disk images here. So what do we want to do next? We want to create partitions. And how do we want the partition table to be? Well, we want to have about 90% should be the main Linux disk, and around 10% should be swap area, at least by default. But I want to have some additional limitations on this swap thing. like let's say 10%. Let's go to the man page for SFdisk and see what's possible with this tool. Maybe we can even tell it to do 10% of the disk or something. Can I see examples somewhere? You know what? Let's use SFdisk and create a partition table on XDA the way we want it, and then let's see what output we can get. So if we run SFdisk on XDA, sbin SFdisk. Alright, so let's create a new partition. And if we want 10% to be swap, so 31.2, so it should be just 3 megabytes in this case. Well, it doesn't really matter the sizes. So let's say 3.12 megabytes. And let's create one more, and this should be the rest. And this should be of type swap. Alright, so this is the file system we want. So let's write yes and quit. So how do we use SFdisk now to get information about this thing? Activate dump. -d, okay. So if we run sbin sfdisk -d xda, okay, so we get something like this, right? So this is what we want to recreate. But what does it say? LBA and stuff. So we need to know the sectors, I guess. So here we list the different partitions, and so this is the block where the partition starts, and this is where it ends, and then we have this all the way to this. and the types look quite difficult to interpret, but I guess the type for this swap area always is this. And the UID, I guess we can just use this maybe. But how do we figure out the LBA, so the number of sectors? And do we really need to do that, or can we do it another way? Could we, for instance, instead of first LBA, say, I don't know, size or something? Because we don't want to overcomplicate stuff. Do we have some examples? Here we do. List label. Create 3 Linux partitions with a default start. The size of the first 2 partitions is 10 megabytes, so 10 M. Could we do 10% perhaps? Let's try. Let's try on SDB. So if we print F and we say 10%, I don't know what this L means, but let's keep it for now. So 10%, and then the rest. Okay, it did something. So what did it do? Created a new partition of type Linux and size 5 kilobytes. That can't be right. Let's see, this is 10 meg, so it should be 1 meg. Must be possible somehow to use percentages, right? Size is equal to here. Size is equal to number. Specify the partition size in sectors. The number may be followed by the multiplicative suffixes. Then it's interpreted as size in bytes, and the size is aligned according to blah blah blah. But do we really need to make the swap 10%? That was just a suggestion, actually. Maybe we can base it off of available memory instead. That actually makes more sense. So we can use the free command to figure out the total amount of memory. So let's see. No, this output is better. So we want to grep for mem, and then we want to take the second word, but there's a lot of spaces here, so we can't use cut. We need to do awk and print the second word. There we have it. So let's create a function which figures out how much memory we have. Let's see. So we want to have at least double our memory, but we want to have some minimum and some maximum, I think. So let's say mem should be swap should be mem times 2, but no less than no less than 8 gigabytes, let's say. And no more no more than 32, perhaps. Let's say that. Alright, so let's create a function which is get swap size. So we let size be equal to get mem times 2. And if size is less than, what did we say, 8 gigabytes. I hope Bash can handle these big numbers. Maybe we should deal with kilobytes instead, or megabytes even. Yeah, let's do megabytes. So it should be get mem times 2 divided by 1024 times 1024. So then we have it in megs. And if the size is less than 4, in that case we set the size to 4. And if size is more than, it should be 8. And if it's more than 32, then size is equal to 32. Like so. So let's see what our swap size becomes. How do we grab that return value? I guess we do get swap size, and we set some variable. Let's say size equal to $? Something like this. $31 meg. Is that right? Yeah, I guess it's double of this, and it's within the bounds. Let's just test if the bound was 16 instead. Then it's 16. Okay, good. I think this works. All right. So let's call this swap size. Let's see here. So in our case, well, in our case it should be 31 megabytes, but the whole disk is not big enough for that. So let's instead say 3 megabytes. I think we need to redo this. Let's run this again. Alright, so let's see what it did here. It created a partition of size 3 megs, and it created another one of 6 megs, because the whole thing is 10 megs, so that makes sense. But it made both Linux. I want the other one to be swap. I guess that's what the L stands for, right? So what is swap? What is swap? Is it S or LS? Let's redo this again. And let's say that this one is S. Huh, no, Linux swap Solaris. Let's open this in SFdisk and see how it looks. Linux swap Solaris. Type. Did it look like that before? I can't remember reading Solaris before. Let's see XDA. This just says Linux swap. That's a bit weird. Let's redo this again, and let's try ls instead of just s. Empty. What if we type it out? Linux swap. There must be some way to enumerate the different types of file systems. Type is equal to swap. Type is equal to code. GPT partition. Shortcut as for unnamed fields. Format or a type name. Type is equal to do. Maybe it's correct. Maybe it should say that. seems to be different formats of the actual partition table, like GPT. I'm not sure what that is in this case. But it defaults to probably the old way of doing things. But I still think it will work, so let's do it like that. Let's just say this is S. So we want to create the partition table, then we want to activate the bootable flag for the Linux partition. Or is that done automatically? Let's redo this again. And let's say 3 megabytes swap, like so. And let's open this with SFdisk. No, it does not have the bootable flag, but that must be we must have some way of just issuing a command line command in order to activate the bootable flag. If we search for bootable, here, activate device, switch on the bootable flag for the specified partitions, and switch off the bootable flag on all unspecified partitions. Okay, so partition number. So does it start from 0 or 1? Well, let's just try. So we'll run sbin SFdisk on XDB. We're going to activate partition number 2. Okay. Bootable flag. And we have a Linux partition, we have a swap. So now we have everything that we need. Let's just put all the pieces together. So we need this. So let's see here. We must select what disk to do stuff on. So let's for now say we have a choice and we have selected disk 1. So let's create a device variable, which is going to be equal to the dev directory slash the disks $choice. So that's our device. So when we know the swap size, we want to do this, but we don't need a full path here. And we need to change this 3 right here. And this should be the swap size. And then we run SFdisk on the device, which will create the partition table. Then we run SFdisk activate device, and it's always going to be partition 2 in this case. And that's just about it. Now we just need to show the user a dialog where they can select the disk. So let's comment out these two for now. And let's see how we use this dialog tool. So I'm just gonna test it now. Radial list height and width, let's say 10, 40. List height, let's say 3 or 5. And then we'll just list the different things. So the tag is going to be XDA in our case. And then the description. So let's grab that. Grep logical. So XDA should be this. Then we have XDB. We need need to have a status as well. So let's say this is on. This is off. And then we have XDC with this stuff off. All right. So how do we take care of the return value? If we echo just the return value from the program, what will happen? Get a 0, 0. Do we need to do this perhaps? Still a 0. So how do we take care of the return value? Return status. Normally dialog quotes the strings returned. Maybe if we go to examples by the end here, if there are any. So maybe it just writes it somehow to the standard out. But how is that possible? Maybe to the second one. Ah, there we go. So it writes it to standard error, and it writes the tag. That's pretty nice. So how do we take care of that value? Do we need to use a temporary file perhaps? That's for sure the easiest way, at least. Alright, so we need to create a string similar to this right here. And let's see what other options we want. We want some kind of title, I guess. So a back title and a title. Right, so let's see here. So we need one function to create the string. So let's call it make command line. So this should run dialog. Back title. No bloat Linux. And we should have a title which defines the step. So select disk. What else? Then a radio list. So first we have the text. So where do you want to install Linux? Then we have height and width. We need to tune this a little bit, but let's use these for now. And then the list height, 5. And now we have the different options. Alright, so let's see here. Now we need to make a loop and iterate through all of our disks. And for each disk, we want to add to this str variable bracket like this, and then dollar disks at I, and then the description. So we take the disks, and this shouldn't be I, by the way, it should be N. Not even that, it should be $N. Much to keep in my head. Alright, so that's the description. And then we need to specify if this is going to be on or off. So the first disk should be on. So if let n 0, then str plus equals on. This should be like this. On, else should set this to off. Phi. And done. I think this is right. Let's try it out. Make command line. I wonder if the functions have access to these global variables. They should have, right? We need to echo this thing by the end. All right, something like this. Okay, so this is the command. Backtitle, title, radio list, XDA. Maybe we should put that inside of quotes as well. Right, so if we were to just run this command, why are all of these on? I need to increase n. Alright, that's better. So let's run this. Huh, would you look at that? And look at this nice little thing up here. And select disk, where you want to install Linux, blah 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 blah. Very nice. Cancel, do we really need that cancel? What should happen if we cancel? Should we abort the installation? Okay, so it returns a 1 if we cancel. Is it possible to remove that? No cancel. I really like this program. It's very nifty. Okay, now we don't have any cancel. Alright, so how do we run this command? Can we just do, let's see. What happens if we just do this? Okay, there we have it. So let's see here. Let's create a function for running the dialog. Or maybe we're going to run several dialogues. Let's call this the then we're going to have several command lines as well. So let's call this make partitions, or make part dialog. Almost impossible to read that, but never mind. So make partition dialog. can have show partition dialog. So the command should be make partition dialog. And the return value. So let's see here. The return value should be we need to do some temporary file stuff, that's right. So evaluate the command and pipe the output to /tmp option. And the return value should be, I want to set off these brackets. So let's see here. We want to grab both of these brackets. Just remove them. And the sed in, by the way, this should be dollar like this. And the sed input should come from TMP option. And then we just return ret. No, we can't do that. Because we want the number and we get the device. So we need to go through the loop. So let n equal 0 for for x in. We should go through all the disks. And if so if $x is equal to the return, in that case we simply return current n. And if we get to the end of the loop, how do we signal an error? But it can't be an error because there's no cancel button. And if they control C, we won't even get here. I think this is correct. Maybe we should return something anyway, just for the sake of it. So we want to run show part dialog, and then we set this to $?, and out of that we grab dev directory. So down here we should be able to print the device if everything worked. Right? I think this is correct. Okay, so let's say we select XDC. No, we still get XDA here. Why is that? Show part dialog. Maybe the sed doesn't do what I want it to. Let's try it in the terminal. So what we have here is XDC, and if we run sed E and we change this and this to nothing, G, does not work. Weird. What if we were to do this or this? Well, let's do this instead. And then we do another one which changes the other thing. Still XDA. Did I mistype it? This to nothing. This to nothing. What do we have inside of this temp opt then? XDA like that. Well, that actually makes sense. But it actually writes XDA to the file. Okay, now it worked. Okay, I need to select it with space. Then we should have a default option. Something like this. And then we don't need this because all of them will always be off. Need to make this a bit bigger, I guess. Can we return a minus? Maybe we can say that maybe we can have something like 999 if it's an error. That's probably too much, but 99. So if let choice equal to 99, then echo error 5. Okay, so there we get an error if we pick the unselected item. And if we select XDB, still get an error. Ah, no, we need to space it. Okay, that works. So if we select the if we try to select with just enter, we should give an error message. So let's do something like while true do. So we have a loop here. Until we don't get an error, we keep iterating. So let's see, instead of echo error, let's say we have an error function, or error function, and we say something like, you need to make your selection with space bar, like so. And then we can have a, let's see what they call it. Is it a message box? Let's try that. A skill box. Hello world 10.5. 5.10. 10.40. All right. Can we signal somehow that it is an error? Maybe a different background color or something. Size error. Interpret embedded sequences in the dialog text by the following character. But what about background color? Maybe we can make the text red then. So /z1 cn. So let's see here. $13.40. So something like this. Okay, works. Almost. If let choice is equal to 99, I thought this worked before. Ah, wait a minute, I forgot space. Funny, I don't even read my own error messages. Okay, that's great. So everything works now. So let's see if we can actually create a partition table. Let's reset the XDB and let's delete this and let's run this. Scripts, make part. We want to select XDB. Okay. Alright, something happened. Let's see what it did with the disk. It created a partition table. We have a Linux swap. Of size 0. Okay, that's because this disk is too small. Let's make this a little bit bigger. So instead of 10 megabytes, let's say 100 megs. Right, because we're dealing with megabytes currently. We need to remember to change that to gigs later on. But it's good for now. Okay, so now we have a 100 meg disk. Select it, we create stuff, we go into our disks, SFdisk. Alright, so now it looks right. We have 31 megs for the swap, which is a maximum, and we have 68 megs for the Linux, which is bootable. So, ladies and gentlemen, we have successfully created a partitioner. Not bad, eh? So, the only thing left for phase 1 is formatting the disks and copying the necessary files. But I think this will be enough for one day. We have gotten pretty far. So I really hope you liked this episode. If you like Linux, I'm sure you've had the possibility to learn a lot. Please don't forget to like and subscribe. And next episode will continue. So thanks for watching. Thanks for tonight.